Welcome to WebCool. Now today we will discuss the topic number system. Actually, this topic is class 9th from RD Sharma, and we will discuss it. So, number system. So, what is a number system? Actually, number system is a way to represent and work with a number. It includes different type of numbers and their classifications. Here's breakdown of the basic components. Natural number, okay. Now we take a pen. Oh yeah, natural number, it is denoted by n. Okay, so what is the definition of a natural number? Number used for counting and starting from 1, 2, 3, 4, 5 and so on. It not included 0. Okay, when if included 0 in the collection of a natural number, then called the whole number. Whole number, natural number plus 0, natural number and plus 0 called whole number. Okay, so this is an example of whole number: 0, 1, 2, 3, 4, 5. This is the example of 0 number and so on. Okay, and now we take another term, integer. Integers, okay, it denoted by z. So what is the definition of integer? All whole numbers including negative plus positive. Okay. For example, -3 is a negative, also -2, -1, 1, 2, 3. These are the example of integer, right? Now we move another slide. So rational number. Now we will discuss the rational number. What is the rational number? What is the rational number? Number that can be expressed as a fraction of two integers a by b. Okay, where b not equal to 0. Where b not equal to 0. Suppose this is a fraction. Okay, this one a, this one is a b. Okay, when b equal to 0, when b equal to 0, so this term, that means suppose a by 0, so the entire term is undefined. Okay, like something. Okay, so we try to be not equal to 0. We try to be not equal to 0. So some example of a rational number: 1 by 2, -3 by 4, 5. These are the example of rational number, and it is denoted by q. Okay, rational number include integers and decimals that terminate or repeated. What is the terminate? What is actually terminate? Suppose 1 by 2. When solved these fractions, we got 0.5. These are the example of terminate. After decimal, digit is 5, and it is not continuously increasing. 5, it is not continuously grow. 5, 2, 5, 3. It doesn't show here. Okay, it's only 0.5. So that means it's a terminating. Okay, terminate after some digit. And now we move on repeating. What is the repeating? What is it? Repeating. Okay, suppose we will take another example. What will, okay, 10y 10y 10 by 3. Okay, 10 by 3, how many times 3 divided by 10? 3 times. Okay, 3 3 is a 9, remaining term is a 1, because 1 is less than 3 and we put decimal, so this value is 10, and again we will divide it by 10 by 3, so 3, and it divisible by 3 times. Okay, 3 3 3 3. This is the example of repeating decimals. Okay, so I think both terms clear. Now we move irrational number. Now irrational number. What is irrational number? Number that cannot be expressed as a simple fractions. Simple fraction like 1 by 2, 3 by 4, so something. Okay, these are the example of simple fraction, and the number that cannot be expressed as a simple fractions, their decimal expansion are non-terminating and non-repeating. For example, under root 2, we know the value of under root 2 1.414, I think. This is the value of under root 2. Okay, and suppose take another example, pi. What is the value of pi? 3 point something. Okay, so these are the example of irrational number. Okay, decimal expansion are non-terminating. Non-terminating, that means it expands continuously, like 1.414 dash 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 dash. Here is something. Here is some digit of under root 2. But after it matters after decimals 3 to 4. Place of digit is important. Okay, so these are the irrational number. These are the example of irrational number. Now we move student another slide. So in this slide we will discuss the real number. Okay, real number. Real number, it denoted by R. Okay, what is the definition of real number? All rational or irrational number. You can see in the example minus 3. Minus 3 is an example of real number. And here is under root 2. Here is under root 2. Previous slide we have to discuss under root 2. Under root 2 is a irrational number. Okay, irrational number. So real number is all rational and irrational number. Okay, here is some example of a real number. Now we move complex number. What is a complex number and what is a complex number? So complex number is a number that include a real part and imaginary part. Okay, imaginary numbers are multiple of under root -1 denoted by iota. Okay, so here is an example of complex number 3 plus 2i. So this part is a real number as I read in the definition, and another part is a imaginary number. imaginary part. So when add both part, that makes the complex number, and it denoted by C. Okay, now we will move to the another slide. In this slide, we will discuss key properties of the number systems. First, commutative property. Commutative property for additions and multiplication. Okay, so here is an example of commutative property. A plus B equal to B plus A, and we will convert it into any number. Okay, suppose 4 plus 7 equal to 7 plus 4. When add 4 plus 7, we got the value 11. Okay, and here again we will add two numbers, 7 and 4, we got 11. When we will change the place 7 4 and we will interchange the place between two numbers, it doesn't affects on output, doesn't affects on answer. Okay, so 7 plus 4 equal to 11, and we will interchange the place 7 and 4. Again we will add it. Yeah, we got the 11. So it doesn't matter when you will change the place between 7 4 and any other numbers like B plus A plus B. So it doesn't affect the output. Okay, always output is the same. Now we take another term, associative property. Associative property, as the word suggests, associate, that means something is grouping, does not affect the sum or products. Okay, like here is the example, A plus B bracket plus C equal to A plus B plus C. Okay, suppose we converted any numbers like a 1 B for 3. Okay, 1 plus 3 and C for 4. Okay, equal to A for 1 plus bracket B for 3 C for 4. When we will solve it, we got 3 plus 4, 3 plus 1 equal to 4, 4 plus 4, 8. Okay, same here, 1, 3 plus 4, 7, and finally we got 8. Both side answer is same. So that means it doesn't matter if you change the place of any number and any digit. When you perform the addition, operation, it doesn't affect the output, it doesn't affect the final answer of the problem. So okay, what is distributive property? Distributive property, it is example of distributive property. A bracket B plus C equal to AB plus AC. Okay, it convert in any number. I take another example like 3 2 plus 1. Okay, 3 into 2 3 into 1. Let's solve it. 2 plus 1, 3. Okay. 3 into 3, 9. Okay. Here, when solve this part, 3 into 2, 6, plus 3 into 3, 3. 3 into 1, 3. And finally, we got 9. Both are the answer is same. So it doesn't matter if the value of one value of same, and we put out the bracket because it is a common terms, so a common term associated with every terms, and we put out we put out it from the bracket and perform operation according to sign, and we got the same answer before it associate with them. Okay. Identity element. Identity element. For addition, the identity is 0. For multiplication, it's 1. Okay. Now we move another terms, inverse element. Every number has an additive inverse, negative, and multiplicative inverse reciprocal except for 0. Suppose here is an example, like 2 to the power minus 1. It is minus 1. Okay, 2 to the power minus 1. That means 1 by 2. Okay, something like, okay, 1 by 2 to 1 by 2 to the power 1. Here is another example, 2 to the power minus 2. It is a reciprocal power, and the value 2 move denominator 2 to the power 2. In this terms, additive inverse and multiplicative inverse except for 0 in multiplication. So it is the summary of that. Now we will move the another term, represents 5 by 3 and minus 5 by 3 on the number line. It is a question. Okay. Now we will solve it. First, we will solve it step by step. First, divide the space between whole number into third. Since the number are in the third, divide the space between each integer. Actually, this is a number line. Okay, this is a number line. It is a 0. Okay, right side of the 0 value is positive, and left side of the 0 the value is negative. Okay, minus 1, minus 2, minus 3 something. Okay, look at 5 by 3. First, find the 0 on the number line. Yeah, this is a 0 on the number line. Okay, we have to find it. Now notice that 5 by 3 is equal to this is something. 1 is to 2 by 3. Okay, 3 1 into 3 3 plus 2 5 by 3. Okay, and we also write 5 by 3. 1 is to 2 by 3. Okay, which means it is a little more than 1. That means something like so. It is a little more than 1. Okay, little more than 1. Start at 0, move past 1, move past 1. Here is a 1. Okay, and go 2/3 of the way towards two thirds. That means something here. Okay, 2/3 of the way towards 2. Here is 2. Okay, mark that point as a 5 by 3. Here is a mark point. This is a 5 by 3, and similarly we follow left side of this number line. Okay. Find 0 again. Yeah, we have to find 0 on number line, and now notice that minus 5 by 3 something is minus minus 1 plus 2 by 3. Okay, let's solve it. Minus 3 minus 3 minus 3 1 minute. Okay, so when draw a number line, okay, and it is a reference point. Now notice that minus 5 by 3 is equal to minus 1 is to 2 by 3. Okay, minus 1 is to 2 by 3, something like 1 plus minus 2 by 3 minus 3 or minus 2 minus 5 by 3. Okay, we raise it. This is a number line, and it is a negative region, it is a positive region. Left side of the 0 is a negative region, and the right side of the 0 is a positive region. And notice that minus 5 by 3 is equal to minus 1 is to 2 by 3, or which means it is a little less than minus 1. Here is a minus 1, little less than or minus 1. Start at 0, move past minus 1, and go 2/3 of the way towards minus 2. Okay, here is a minus 2. Little this is a minus 1. It is a past of minus 1, and go towards minus 2. Actually minus 2 is less than minus 1, so we move towards minus 2, and 2/3 of this way, minus 1 to minus 2. Mark the point. Suppose here is that point. Okay, and minus 5 by 3. Okay, now decimal representation of rational numbers. A rational numbers is any numbers that can be expressed as a quotient or fraction of two integers, like something like 3 by 2. Okay, two integers where the numerator is an integer and the denominator is a non-zero integer. Suppose p by q, he can say, it can say q not equal to 0. Okay, q not equal to 0. In mathematical terms, rational number is any number of the form p by q. Okay, Rational number p by q is a positive rational number if p and q are of the same sign. Suppose p by q is a positive rational number. Let example 3 by 2. It is a positive rational number because plus 3 is a positive and 2 is also positive. So that's ultimately make the 3 by 2 is a positive rational number. Okay, because p and q are of the same sign. Suppose 3 is a p and 2 is a q, both are have the same sign, so that's why it is a positive rational numbers. If p by q are such that they have a different sign, p have a positive and another one have a negative sign, then the rational number is a negative, like minus 3 by 2. Minus 3 have a negative sign and another number 2 have a positive sign, so both have a different sign, so that's why it is a negative number. Negative number. Okay, so here's the example of a rational number 1 by 2, that is a 0.5. Actually it is a positive rational number. Positive rational number when minus 1 by 2 and we got the minus 0.5, it is a negative rational number. Negative rational number. So it is all about the representation of a decimal representation of a rational number. And now we'll move to the next slide. Okay, it is a problem based on rational number, based on rational number 7 by 8 in the decimal form by long division method. And actually questions say, and yeah, you will use long division method for solve this question. Okay, we will solve it. We will solve it 8. It is a quotient. Okay, dividend, divisor, and this is a remainder. Okay, the dividend is 7 and divisor is 8, and here you can see dividend is less than divisor, so it is impossible. So how to divide 7 by 8? And we put decimal, so we put decimal, and that means 7, not 7, it is a 70. And now 70 is divisible by 8. How many times? 8 divided by 70, 8 times, because 8 into 8, 64, and 70 divided by 70 minus 64, we got 6. Okay, this 6. Okay, its remaining term is 0. Write down at 0, and further we divided 60 by 8. How many times? 8 divided by 60, it is 7 times, because 8 into 7, 56, and subtract 56 from 60 and we got 4, and further we write down 0 and we got this value 40. And in the table of 8 we know 40 is a factor of 8. Yeah, 40 is a factor of 8. How many times 8 divided by 40? It is 8 into 5. 8 5s are 40. Okay, 8 5s are 40. So here's the 40, and 40 minus 40, and we got 0. 0 is a remainder. 0 is a remainder of 7 by 8. When we divide 7 by 8, and we got the remainder 0. And it is the decimal quotient is 0.875. It is a decimal representation of 7 by 8. Okay, using long division method. Now we will move to another slide. Conversion of decimal number into rational number of the form. When the decimal number is of a terminating nature. Okay, terminating nature, that means after certain digits number is the number is end, like 1.2, 0.5. Okay, 0.5, something 1.4, 0.25. After certain number, the number end, the numbers is end. Okay, after 5 no more numbers, after 0.25 no more numbers. So that is the example of a terminating nature. Okay, when the decimal representation is of a non-terminating natures, and that means 1.3. okay, 1.3 when divided 1 by 3, so we got 0.3333 something. Okay, and after decimal we got continuously, it follow a pattern. It follow a pattern like 3 continuously. Okay, this is the nature of a non-terminating. This is the nature of non-terminating. This is example of a non-terminating. Okay, conversion of terminating decimal number to form p by q. Previous slide we have to discuss any number p by q in the form of p by q and convert it to decimal form, right? And we have to use long division method to convert fraction into decimal. But in this slide we have a terminating decimal, and then it convert into p by q form and fraction form. So what is the step? We should follow. First, obtain the rational number. Okay, first obtain the rational number and determine the number of digits in its decimal part. Okay, determine the suppose obtain the rational number, and first determine the number of digits in its decimal part, something like 0.25. Determine the number of digits in its decimal part. Here is 2 digits in its decimal part, 2 and 5, 2 digits. Okay, remove the decimal points from the numerator. Remove the decimal point, something, this is a numerator and this is a denominator. Okay, denominator. Why write 1 in the denominator? Yeah, 0.25. Here remove the decimal point, we have to remove it, and write 1 in denominator, and put as many 0 on the digit side of 1 as the number of digit in the decimal part of the given rational number. So here we can see 2 and 5 is the two digits after decimals, and we write 20 right side of the 1. Okay, if three digits in decimal part, and we write 30 right side of the 1. So it is a vary according to a digit in the decimal parts. Okay, find a common divisor. So something it is a something 25 by 100. Okay, find the common divisor of a numerator and a denominator, and express the rational number to lowest term by dividing its numerator and denominator. Lowest terms, rational, express the rational number to lowest term by dividing its numerator and denominator. So his common divisor is 5, because 5 divided by both 25 and 100 divided by 5. So it is a 5 and it is a 20. And further we will solve it, and we got 1 into 4. Okay, it is the fraction of a given decimal. Okay, we take another example how to convert decimal into fraction form. Okay, let's say another example of a related to this issue, related to this problem, like 0.15 we have 0.15 equal to 15 by 100. Okay, 15 by 100. Okay, 0.15. Okay, and because 0.15 here is a, this is a decimal. After decimal, how many digits? 2 digits. So that means when we remove the decimals and put denominator 1 and put 0, according to how many digits after its decimal. So here is a 2 digits, 1 and 5. So that's why we put 20 after right side of the 1. Okay, so this value is a 15 by 100. 15 by 100, and it's a common divisor. Common divisor is 5, because in the table of 5, 15 and 100 is a factor of 5. Okay, 15 divided by 5 and 100 divided by 5, we got the 15 divided by 5. That is how many times 5 divided by 15? It is 3 times. Okay, and how many times 5 divided by 100 is 5 times. Okay, no 5 times 25. They have to miss something. Yeah. Let's try. Everything is right. Okay, so the fraction value of 0.15, what is the fraction value of 0.15? Is 3 by 25. Okay, this is the our answer. Okay, now we will move the another slide. In this slide we have to discuss conversion of a pure recurring decimals to the form PQ. Okay, digits after the decimal points are repeated. Suppose here is the example. Here is the example 0.6 bar. 6 bar, that means 0.6666 and so on. Okay, digits after the decimal points are repeated. You have to notice this is a decimal point, and after this decimal point the digits are repeated. 6, again 6, again 6, again 6, and so on. Okay, follow this pattern continuously. At least one of the digits, and here is another terms, at least one of the digits after the decimal point is not repeated, and then some digits or digits are repeated. Like it is another example, 2.16 bar to 2.16 bar. Okay, and here is another example of 0.1 bar. That means after the decimal, one is continuously repeated. Okay, in this section, not one, this is my mistake, it is a something 2.16 bar. Okay, but not on 1, actually it is on 6 only. So that means after decimal 6 is not repeated. So what is not repeated, then some digits are repeated, not whole digits are repeated after decimals. Here is 6 are repeated, not 1 is repeated after decimals. Okay, now take this questions. 0.1 bar, let x equal to 0.111. Okay, and this is equation 1. Okay, now we multiply both sides by 10, so this is a 10x, and this will 1.11. Okay, and it is equation 2. Okay, on subtracting equation 1 from equation 2, and we get equation 1, subtract equation 1, this is equation 1 from equation 2, that means 10x equal to 1.111 equation 2, and what is equation 1? This is equation 1, x equal to 0.1111. So what will we get? Actually you have to get, we got 0.00001 equal to 9x. So 9x equal to 1. So what is the value of x? X equal to 1 by 9. Okay, so this is the fraction value of 0.1 bar. So what is the value of 0.1 bar is, what is the fraction value of 0.1 bar? That is 1 by 9. Okay, now we will move to another slide, and we have to discuss. Here is another problem. Okay, this is a point 3 bar, not only bar only on 2. Okay, not 3. No, it not included 3. Okay, so here is the example, and clearly there is just one digits on the right sides of the decimal points, which is without bar. So here is a 3. You can see it. Here is a 3 that have a no bar. Okay, only one digits after decimals that have a no bar, and so we multiply both sides of x by 10, so that's only the repeating decimals is left on the right sides of the decimal points. So it is a 10x, like something 10x, we multiply both sides by 10x, and this value is 0.32 with multiply 10, so we got 3.2, right? So this happened. So 10x equal to, we can write it as a 10x equal to, we also write as a 3 plus 0.2. Okay, 10x, we remove it. We remove it. 10x, now take pen. 10x equal to, we also write it 3 plus 0.2. As we learned in previous slide, 10x 3 plus, we write it, and when remove decimal, it is a 2, and put 1 in denominator and put 0. How many 0 we will put after right side of 1, according to how many digits after decimal. So in here only one digit after decimal, that is a 2. Okay, and put 1 0 after right side of 1. Okay, so this value is 2 by 10. 2 by 10. Not put 0, actually 0. Actually put how many digits after decimal? 1, and when remove decimal, we put 9 in denominator. Okay, put 9 denominator, because after decimal, why put only 9 denominator? Actually it is a very according to how many digit after decimal. So actually in this scenario only one digit after decimal, so that's why we have to put only 9 in denominator. If suppose 0.2222, okay, in this case we have to put denominator 99. Why 999? Actually after decimal, three digits in numerator, so that's why we have to put 39 in denominator. So it is the funda of this problem. So, okay, so it is a 10x equal to 3 plus 2 by 9. Okay, now we have to solve it. 10x multiply 9 into 3 plus 2 divided by 9, because 9 is LCM. So 9 into 3, 27 plus 2 divided by 9, 27 plus 2, 29, 29 by 9 equal to 10x. Okay, when 10 move to denominators, that will 9 into 10, so 29 by 90. So this is a final answer, x equal to 29 by 90. Okay, now we will move the another slide. It is a irrational number. I have to discuss in previous slide what is a irrational number. Something under root 2, pi. These are the example of a irrational number. So what it is a 3 types: terminating and non-terminating, but repeating, non-terminating and non-repeating. Okay, terminating. Okay, terminating numbers That means after certain digits, after certain digits, it- after certain digits, it is not continuously increasing. It is after certain digits end. Okay, and after certain digits. Okay, something 1.2 to 0.5 and up, and after certain digits, that means it is end after 5, no digits after 5. That is an example of a terminating nature of it. So the terminating nature. Okay, non-terminating but repeating, that means non-terminating but repeating. Something 2.1, 2.1, it is the example of non-terminating but repeating. You you have to notice here 2 1 2 1 2 1, follow 2 1 2 1 2 1 continuously grow, and 2 1 2 1 2 1 is repeating. 2 1 is, here is the 2 1, here is the 2 1, here is the 2 1, here is also 2 1 2 1. So it is the nature of non-terminating and repeating. And now we have to discuss non-terminating and non-repeating. Non-terminating and non-repeating, that means 1.2 2 3 5 4 7 9. ठीक है, 1 1 2 3 2 2. It is the example of non-terminating and repeating decimals, because the after decimal, it not follow any pattern, not follow any pattern, and not follow some digits are continuously repeating. Here's a absent after 2, after decimal 2 3 and 5 4 7 9 1 1. Okay, so here is an example of a non-terminating and non-repeating, except this part of it number of it. Okay, so thanks for watching video.